This is Chapter 3 Selections, Programming Exercise 15, Lottery Game. So for this programming exercise, we're going to generate a lottery of a 3-digit integer. The program is going to prompt the user to also enter a 3-digit integer and determine whether the user wins according to the following 3 rules. So rule 1, if the user input matches the lottery number in the exact order, they win $10,000. Rule 2, if all digits in the user input matches all digits in the lottery number, they win $3,000. And lastly, rule 3, if one digit in the user input matches one digit in the lottery number, then they win $1,000. Alright, so let's try to tackle this Java exercise. Now for this exercise, the first thing I want the user to visualize or understand is how we're going to generate this 3-digit number. What is the proper way and what do we have to look out for? So the lotto number and the user input must follow the following criteria that I have right here, right? There could be more, but for now, let's follow these rules that we should apply in our programming exercise. Now this little example we have here, let's say X represents the lotto number and also the user input or their lottery guess. This X, right, this lottery number always have to make sure to be greater than or equal to 100 and less than or equal to 999. So why specifically any number between this range, 100 to 999? Well, we're going to just be generating a 3-digit number. And within this range, those are the only possible 3-digit numbers. Anything less will be considered 2 or less digits. Anything greater will be considered 4 or more digits, which is not what we want for this exercise. All right. So for following this criteria 1, the generated lotto number must be 3 digits, no more, no less. Criteria 2, the lotto number cannot be changed after it has been generated. So if I randomly generate a lottery number, nobody from the outside or the inside should be able to manipulate that lottery number and make it into a number that they know or are aware of. That will allow the user to cheat the game. Criteria 3, for the user, if the user enter a non-3-digit integer, which is like a 1 or 2 digit, 4 or 5-digit number, then they did not enter the correct guess, right? They have to specifically enter a 3-digit number. If they don't, they're going to break the game. They're not following the rules. So if that happens, you could either terminate the program or you could ask the user to try again and make sure at this time the user enter the correct 3-digit number. And if they don't, then go back to 3A and terminate the program because the user did not follow the rule. All right, so with all that explained, I don't want to jump into the next one and continue, try to break it down onto the next part and cause a lot of confusion. So what I'm going to do is immediately jump into the code and try to solve for this first. All right, so let's try to solve by generating a 3-digit number. Now, before I do that, let's understand the possible data types I could use, which are byte, short, int, float, and double. Now, which one I use is important, and that's because each data type here represents a different size and a different limit. For the bytes, if I was to use the bytes, there's a limit to how much or how big the number could be, right? The lotto number could be 100, but it can't be anything greater than, let's say, 300, right? Or 200, but it could be 100, it could be 126, but it can't be anything greater than 126, which will be it can't be anything greater than 127. Anything greater than 127 there's an error. And that's because this byte value could only hold up to a certain size, up to a certain number. Anything greater than that, it cannot hold that value. So you have to, when it comes to development, you have to know what kind of data types you're going to use, how it will impact your program, and you have to make sure to be memory efficient, right? Byte is the smallest data type that could hold a very small value, and double could hold a very large value. We don't always want to use bytes if we have a large number, but we don't have a large number, we don't always want to use double and take up more memory than needed. So in this case, what I'm going to do is, I think I'm going to try to use the short data type for now, which of course could take in 128, right? And that's could definitely take in the minimum 100 and the maximum value that we're going to generate, which is 999. So with that understanding out the way, let's work on generating a random number that's going to be 3-digit long. And what we're going to do, we're going to generate a random number using the math class. Now the math class have a random method, and this method randomly generates any number between 0 and 1, never greater. Now, you might be wondering, okay, if it generates a decimal number and we need a 3-digit number, how are we going to utilize this and be able to randomly generate a number that we need, right? That could suit our exercise. Well, in this case, pretty simple. We're going to generate this number and we're going to actually multiply it by 1000. Now, by multiplying by 1000, we'll always guarantee to get a number that's 999 and less, which is going to suit our need. All right. So as you can see, now we are definitely getting the 3-digit number. The only other issue we are getting so far is that, hey, there is also this, decimal right here, which we don't want. So how do we solve that? Well, we could solve that by turning this floating number into a whole number. And in this case, since we're using the short, why not cast this number to be a short, right? And let's see if this solves our issue. Now you might be wondering, all right, if we cast it, oh, what's going on? Why are we getting a 0 now? We're casting this number and we're constantly, each time we generate, we get a 0. Now the issue is because the short is casting math.random. Math.random is generating a number between 0 to 1, right? Between 0 to 1, and it will always be a decimal number. And short is a whole number. So you're casting that decimal to a whole number and it'll always be a 0. So to fix that is we want to make sure we put this parentheses in the right place. So now it will perform this calculation, then it'll cast to short, all right? Now that solved one issue, right? Now we get something like 974. But there's actually another issue here that might take some time before I'm able to actually show you. So we're gonna, here we go. What's going on? We're multiplying by 1000, we casted it short, we got our whole number, but we are not getting a 3-digit number. We want to get a number that is pretty much between 100 and less than or equal to 999. In this case, this X represents the lottery number. But if we get a 59 and we generate that, that's going to cause issue to us. So what's going on is that math.random is generating some number and you're multiplying it by 1000. So you could end up generating a number like 59, which, for example, it could just generate 0.0059. 0.0059 multiplied by 1000, you're not going to get a 3-digit number, or all you're going to get is a 2-digit number, right? And that's not what we want. So we have to solve for that issue. So once again, let's try to manipulate this math.random to solve this issue for us. So what can we do? Well, we know that we want a number that's going to end up being 999. So what we're going to do is we could change this right here to 900. But that means it's going to now generate any number between 0 all the way to 899, right? Anything less than 900. We don't want that. So how do we fix that? Simply just add 100. Bam. Now, by adding 100, you're adding 100 right here, and you're adding 100 right here. So now this equal to some number between 100 all the way to 999. Okay, so hopefully that visualization makes sense. If we were to run it, we will now never get any number that is less than 100, and we'll also know that we'll never get any number greater than 999. All right, so with that out of the way, we're going to grab this and we're going to paste that in here. Okay, let me try to understand. Okay. Once again, because we're adding 100 to this value right here, we're casting this right here to be a short. But by adding to this, short plus integer equals integer. Okay, so simply put this entire thing. Actually, I don't even have to do that. Move this, put it here. All right, so what's going on is it's going to perform the multiplication first, then it's going to add 100. But in case you're worried that won't perform the multiplication first, put the parentheses here, and that will let Java know to perform this inner parentheses, equation or math, and then perform the outer. All right, now here we go. Now when we display a lotto, now that we have generated a lottery number, we will always get any number from 100 to 999. All right, now here's the other issue that I mentioned earlier, and that issue being the fact that the lotto number cannot be changed after it has been generated. What I meant is, hey, it's 798 now, but what if the user say, I'm never going to be able to guess this. This is super hard to guess, so I'm going to try to cheat. I'm going to say, hey, let's say lotto equals to 100, and I'm going to guess 100. That way I'll always win. Well, we don't want that to happen, right? That's cheating. No cheating allowed. So what we're going to do is to use the final keyword. Now the final keyword is saying that whatever has been set into this variable is now final. It can no longer be changed. It is set, whatever you set it to in the first place when you initialize it, that is the number forever until the program ends. And that is exactly why you get an error here. Now this error say, hey, I can no longer assign a value to the final variable, lotto. I cannot change it. So you get an error message, which is perfect, and that's exactly what we want. That will prevent anybody from changing this value after I have randomly generated a number to it. All right, now we are finally done. All right, we have generated our random 3-digit number. Okay, so now we could finally move on to the next thing. All right. Well, actually, I didn't realize I forgot about number 3. So actually, let's tackle number 3 first. All right, so I generate a number that's 3-digit, no more or no less. And number 2 says lotto number cannot be changed after it has been generated, which I did that with the final keyword. And then number 3 says that the user enter a non-3-digit integer, fail them right away. All right, either fail them or ask them one more time. So let's try to do that. All right, so scanner input equals new scanner system.in. All right, let's see. We're going to ask the user system.println enter a 3-digit number. Bam. Okay. And let's say we'll just call it guess. And of course, it's going to be stored in a short data type. Let's just call it guess. All right. And we're not going to make it final, right? And that's the reason for that is because if the user did not guess it correctly, it did not enter a three-digit number, you want to give them a second chance in this exercise. Okay, so what I'm going to do is to create something called a label. And this label is going to be called outer scope. All right, but I won't really go too much into it yet. What I'm also going to do is to create a byte that holds the winning the winning number. Should I call it win or lose, or the value, the guess value, chance value, chance. What is the chance? Chance, and I'm going to set it to -1. All right. Now, this whole thing might be a little bit confusing here, so let me slowly explain what's going on. What I'm going to try to do for this exercise is I'm going to use a switch case that's going to take in this chance here, and depending on what value this chance is, it's going to display something differently. So by default, let's say system.out.println you've lost the game. The lotto was let's say lotto. And then we have, we'll break out that. All right, now what's going on? Let's go back to what the user is going to guess. So after we randomly generate a 3-digit number, we're going to ask the user to also guess a 3-digit number to compare it to the lottery number. And this guess variable is going to store the user's input. And it's not going to be a byte. Next, short. Okay. Now what's going to happen is inside this outer scope, that's where we do a check. If the guess is less than 100, or the user guess is greater than 999, we're going to do something in here. Say system.out.println. Actually, just print. You did not enter a 3-digit number. Enter again, and we're going to say we're going to let the user enter again. Input next short, and then we're going to do one more check. And this check, if it actually entered this check, we're going to say chance now equal 0. All right, so what's going on? Let's actually run this before I do anything, right? So the first thing that happens is that the lottery gets generated. A random lottery gets generated. After it gets generated, then I'm going to ask the user to enter a 3-digit number. Now in this case, if I did enter a 3-digit number and enter it correctly, nothing really happens except it does a check right away, right? It just jumps straight in and it does a check right away. Which doesn't really matter for now. But what I really want to show you is what happened if the user did not enter a 3-digit number, right? So it goes in here and it says, hey, let's see if you enter a 3-digit number, and if you didn't, it'll jump into this if case and say, oh, looks like you enter a number that's less than 100 or greater than 999. I'm going to give you a second chance. I'm going to ask you to enter it again. And this time, if I enter again, and if for some reason I enter a 2-digit number again, well, it's going to set this chance variable to 0. Now what this chance variable is going to do is, in case right here, case 0, if case 0 for whatever reason it has been set to 0, I'm going to say, you dope, you did not enter a 3-digit number. Yeah. And I'll just say, you entered yes. Bam. All right. So let's get a visualization on that. So the program is going to ask you to enter a 3-digit number. You, of course, you did not. And then it'll say, okay, I'm going to give you a second chance, enter a 3-digit number. And this time you try to enter a 3-digit number and you enter a 4-digit number. And it'll say, hey, you dope, you did not enter a 3-digit number. You enter 1,000. You lost the game. Which I don't really need to say that. All right, so hopefully that makes sense. And what I'm going to do is to now break outer scope. So if the user lost the game, I want them to break out and go out here so it could immediately jump to the switch case and break out of this scope. So anything within this scope will now no longer run. All right, and the reason for that is because I'm going to do a lot of work within this scope right here. Now let's see. So the next thing I want to do is satisfy for this chance -1. In this case, it'll be case -1 I'll say for some reason the program did not enter the outer scope. All right, so in this case, by default I set chance to -1, and if for some reason it did not enter this right here, then this value -1 will never get changed by whatever I do inside this outer scope. And because of that, this -1 will always stay the same, and when I go jump into this switch case, it'll see this -1 right away. So hopefully this case will never happen. This is only for my testing to make sure I actually enter this right here. All right, so now with all that completed, right, we now have asked the user to enter a 3-digit number, and if they did it correctly, it will go and do a check, right? And if they didn't, then the program will end. Of course, the check will begin in the next part. For the next part, we're going to try to tackle for the winning lottery number 1, right? Winning lottery chance 1. And it says that, hey, if the user input matches the lottery number in the exact order, then they win $10,000. So this is actually a really easy check. All we have to do is check if the lottery number is equal to the user's guess. So for example, let's say that the lottery number is 100, right? Well, if the lottery number is 100 and the user guess 100, then they'll win the $10,000. So let's code that in here. Let's do a little check, right? So let's say if a lotto is equal to exactly the guess, then we simply say, hey, chance, we'll say chance now equals to 1, and we'll break our scope. Bam. So case 1 right? Case 1 is where this rule number 1, if the user input matches the lottery number in exact order, then the award is $10,000. And that's exactly what we did. Lotto equals guess. Exact order, exact number, set the chance to 1. And then in the switch case, I'm going to display system.print. You've guessed it correctly and won $10,000. Bam. And we'll break, right? We don't want it to continue to the default. Okay. And let's run that. All right, so let's try to tackle that again. Let's say I enter a 5-digit number. Click that, and of course, there's the issue where short does not take in that large of a number, so it'll instantly fail on its own, right? This is another issue with if you use short and try to enter that large, right? So I didn't fail the program failed because I entered a number that's way too large. So let's say 1, 2, 3, 4, 5. And then say, hey, 1, 2, 3, 4, 5 is not a 3-digit number. Try again. So this time, let me actually cheat. I cheated, I put 100 right here instead of randomly generating, but that's to show you if the program is running correctly. So the lotto is actually 100, and I'm going to guess 100. And bam, of course, you guessed it correctly and won $10,000. All right, so let's see what happened when I don't guess it correctly. I guess 101, and they say, for some reason, the program did not enter the out of scope. So let's check that issue. Now this time, it did not set any of these values here, which is not good. And that's because what I did was basically set the default as -1, and I went in, and then none of these passed, none of these happened, so it'll stay as -1. So in this case, it actually did went in. So what I'm going to do is have to change it up. All right, which is fine. So I could just change it up to you to programmer, you didn't satisfy all cases yet. ... That's because I really haven't satisfied all cases yet. All right. To programmer, you haven't satisfied all cases. Perfect. So now that I satisfied case 1, which is if it matches exactly, then they win $10,000. Okay. All right. Okay. Let's jump to the next one. Now, next one says, hey, winning lottery 2. Rule 2, if all digits in the user input matches all digits in the lottery number, then they win $3,000. So what that means is that we're going to now have to check for all possible permutation of the lotto number. So for example, if the lotto randomly generates a number that's 1, 2, 3, then all the possible permutation of it for 1, 2, 3 is 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So now we have to check for this case here. All right, so that's the next thing we gotta try to tackle. And of course, we're gonna jump back in here to tackle it, where we have everything nice and organized. And lastly, say if, and before we do that, we're going to actually have to do something else. So if it ever was to jump past here and we didn't get it right, we're going to have to break some numbers down. Now let's say the lotto number is 1, 2, 3, right? Lotto is 1, 2, 3, And to get the permutation to compare with the guess, and let's say guess is 4, 5, 6, well, we have to break this, actually let's say 3, 2, 1. We have to break this 1, 2, 3 into single digits number and to compare it with the guess into single digits number. All right, that way, that's the only way we could do it to make those guesses. And to elaborate more on what I meant, let's break it down. Let's call it lotto A, lotto B, and a lotto C. We're also going to have guess A, guess B, and guess C. Now, lotto A is going to hold the first value, lotto B is going to hold the second, lotto C is going to hold the third, and with same thing with guess A, B, and C. This will allow us to do the check for the permutation check. All right. Now, to do that, we're going to have to find out lotto A. Now, lotto A, which is going to be the 1. How are we going to get that? Well, to get the 1 in 1, 2, 3, we're going to have to find a way to extract that 1, 2, 3. And that's actually pretty simple. If you divide the 1, 2, 3 by 100, then you'll get 1. So basically, it will be the lotto divided by 100, and you will get the 1. All right, now for lotto B, how are we going to get the 2 in 1, 2, 3? Well, the 2 in 1, 2, 3 is going to be a little more tricky. What we're going to try to do is to mod it, right? If we mod it by 100, we actually get 23, but still haven't got the 2 yet. And after we mod it, we still have to divide it. We'll divide it by 10, all right? So basically it'll be a lotto divided, modded by 100 and then divided by 10, okay? And lastly, for a lotto C, we have to get the 3 in 1, 2, 3, all right? So to do that, let's mod it by 10. Mod it by 10, and we should get the remainder to be 3. All right. So lotto mod it by 10, we should get 3. But of course, I need to do a check. I want to make sure I actually did this correctly, and I could say something like this: lotto equals lotto. New line, A is going to be lotto A, B is going to be B, and C for C. All right, so run that. Let's just say 1, 2, 3 right now, and perfect. Actually, let me make this 1, 2, 3 so I get a better visualization. Oops, no. All right, bam. So now we've broken it down. Lotto 1 is A, 2 is B, 3 is C, which is perfect. All right, so we're going to do the same thing for the user's guess. Guess A, B, and C, and simply just copying it will allow us to pretty much do all of that without writing that again. And of course, guess, guess, guess. Let me see why you won't. guess is a short, and because it's a short, it doesn't. Lotto's a short. Okay, all right, that's fine. I'll just have to cast all this to be a short, which should work, but it isn't, because it's a byte. All right. All right, quick explanation on what happened there, because guess A is a byte, and guess right here is a short. We were trying to store a short, a bigger number, a bigger value or data type into a small data type, and it didn't work. The other way around would definitely work. A small data type being stored into a bigger data type, job will say okay, but not the other way. That's why we got the issue, and that's why we have to make sure to cast it. All right, so now that we have all of that down, we move this. All right, we move this. Right here is to use for permutation checking. Okay, bam. Now here's where it gets confusing and long, so hopefully we are following this, right? Now, what I'm going to do is I'm going to say, hey, Lotto A, time to do some permutation checking. If a Lotto A equals to guess A or guess B or guess C, then time to do some checking. All right. Let's see, if guess A equals one of these, then we're going to go in and start doing a check. And we're going to say if, let's see, Lotto A equals B, Lotto A equals C. So we're going to start with A. If Lotto A, did I jump up there? Equals guess A. And then I say if Lotto B equals guess B, and if Lotto C equals guess C, well, in this case, that's actually the exact number, which basically means that if the user enter 1, 2, 3 and I guess 1, 2, 3, then that's the exact number and they should win $10,000, which for now we don't really want that, but I just want to show you. All right, and we're going to jump back out here. We say if Lotto B equals guess B, and then do an else if Lotto B equals guess C, if Lotto C equals guess B, then we will say 2. All right, now this is pretty confusing, right? But hopefully it makes sense. Hopefully you will tackle it. Guess A, guess B, and if let A equals B and B equals A, B equals A, C equals A, B. Lotto C equals guess B. B equals A. C equals B. All right. Chance equals 2. Else chance equals 3 for now. All right. I'm going to run that. And let's enter a 3-digit number, and this time it will be we'll put 1 2 3, so we'll just reverse that. 3 2 1 programmer didn't satisfy all cases. All right, let me see. All right, so if A equals A equals B, or A equals C, then do a check. If, let's say, A equals A, B equals B, C equals C, yes. So that means if they're all the same, then that's the first prize, but we don't want that. That's kind of useless to me. All right, so what we're gonna do is get rid of this, place that. We'll say B equals C and C equals B. Good. Oh, all right. Let's say A equals B, then B could equals C and A, and then A and C. If A equals C, then B equals A, C equals B, and or B and A. Lost the game. The lotto was 3 2 1. All right, now to satisfy for case 2, you've guessed it correctly, you earn $3,000. And then for case 3, earn $1,000. All right, this is such a mess. I wish I explained it more clearly, but this is just doing a permutation check. All right, you guessed it correctly. Now let's do all the possible permutation check. Of course, 1 2 3 will always get you $10,000 if the lotto is 1 2 3. But let's check for all other cases or other possible permutation, which is all this right here, which is what we're going to do. All right, so 1 3 2. So that is a permutation of 1 2 3, which will earn you 3,000. Let's do 2 1 3. Also a permutation of 1 2 3, earn you 3,000. 2 3 1. So far so good. 3 1 2. And lastly, 3 2 1. Bam. So what happened, all I did was to do a permutation check, all done right here, which simply say, hey, break down the lottery number, in this case 1 2 3, and compare it with the guess, whatever it may be. And if the guess is 3 2 1, 3 is in the lotto number, 2 is in the lotto number, 1 is in the lotto number, then you win second prize, which is basically $3,000. and that is exactly what I've done here, right? So let's just quickly go through it, right? So my first check is to check if any of the number matches. So if I manage to find that any of these number, or any of the first number, so to say, right, A matches with the guess of the first, second, or third number, then I begin my check. And inside here, before when I delete it, was to check for the exact order, which we don't want because the exact order means you win first place. Now, any other kind of orders, which is for the rest of this, is where you win the actual second case or second rule, which will be the $3,000. Basically, if A matches A and B matches C, C matches B, you win. Break out the loop, which is order right here. You break outside of this scope. This scope runs from this curly bracket all the way to this curly bracket. And once you get out, once you jump out with that break out of scope right here, you instantly go right here and you continue straight to the switch case. And that's where you begin your check. You check for all of these possible scenarios. All right. Now, of course, let's say for case 4, which I'll also copy from here. All right. Okay. So all these possible cases that could affect your winning. Now, finally, to the last case. This was a long video. Now, the last one simply say if at least just one single digit in the user input matches a digit in the lottery number, then you win $1,000. So basically what we did in step 2, but we just have to match for one number. Thank goodness. This is so much simpler. So since we already solved for these lotto number right here on top, we're going to just use that again. Simply saying lotto A, if it equals to lotto, guess A, or lotto, what did I do? Lotto A equals to guess B, or lotto A equals to guess C, or I'm just going to copy all that, paste that down here, and do that one more time. This time I'll just change that to be lotto B and lotto C. Paste that in here. Lotto. And bam, that means you win with 3. Okay, and for all other case will be 4, which means you completely lost. And then by default, if for some reason you didn't enter anything from 0 to 4, then you go to default, or it never enter the scope right here, and then you get this case -1. All right, I could finally get rid of this, and we have basically completed the game. All right. This chance initializer is redundant. Let's see why. The inspection points out the case where variable value is never used after its assignment. The variable never gets read after its assignment, which is perfect, right? Because in this case, all right, let's see. Which is fine. Same reason like I said before. Right, because this right here is going to store an integer, and this lotto is a byte data type. So an int can't be stored into a byte, but a byte can be stored into int. So in order for this int to be stored, you have to cast it back into a byte to be stored into a byte. All right, and this -1 here is just for the programmer, for us to really troubleshoot if there's any issue. But now that we have solved for all cases that could possibly come up, it tells us, hey, this -1 is now a redundant value, but not a big deal to just leave it. So, all right. Now, once again, let's do a test. Enter a 2-digit number, it didn't work. Enter a 4-digit number, it didn't work. And it said, hey, you dope, you did not enter a 3-digit number, you failed, the game is over. You enter 444, and the game no longer runs, which is exactly what I want for one of my cases. Now in this case, let's try again. Let's enter a 2-digit number, and they say, hey, try again. And this time, let's actually enter a correct number, 479. And it turns out, ooh, you guessed it correctly and won $1,000. But before I do that, you guess the lotto was, actually you guessed the what's it called? You guessed the permutation of the lottery. You've guessed the permutation of the lottery and won. The lotto was a lotto. You've guessed a single digit in the lotto and won, and then simply copy pasta. Yikes. All right. You've guessed a single digit in the lotto and won $1,000. So the lotto was 145 and I enter 762, which is not good. Good thing I did a check. So let's find out why. How could 145 and 762 be correct? What did I do? I say lotto A equals guess A, or lotto A equals guess B, lotto A equals guess C, or B, A, guess A, B, and C, lotto C. No wonder, here's the mistake. Okay, there we go. It's because this right here always checks. Oh, will always be correct, will always be true. So good thing I did a little check. You've lost the game. Perfect. The lotto was 203. All right. None of these matches. It is not a permutation of it. It's not the exact order, and there's no single digit that matches, which I lost perfectly. So that's correct. Wonderful. Wonderful. All right. Lost again. Man, winning the lottery sure isn't easy. Okay, and to do a check, it says, hey, I won again. You won $1,000. The lotto was 752, so it looks like I got the 2 correct. Okay. 589. Whoa, I was so close. I was so close to getting the permutation. I got put 589. I got 53. The lotto's 538. All right. So let's not push it past an hour, and so let's quickly brief on what we did here. Final short lot. Final stance means that the variable that you apply this to cannot be changed once it has been set a value. This short has been cast to this math.random times 900 plus 100 is because math.random generates a floating point number. So when you multiply by 900, you get a large floating point number less than 900. But by adding it to 100, you're getting a number that's guaranteed to be 100 to 999, and then casting it to short to get rid of the decimal. I have byte chance here, and this chance is to see whether you win first, second, third place or did not win at all. By default, I set it to -1, which I use that value in a switch case, so I could go through all the possible things that could come up. Now this -1 is only meant for the programmer, in case I never satisfy all the possible conditions for 0 to 4 to appear. It's never meant for the actual user, and it helps me to troubleshoot. And Intellij, of course, could tell that this now becomes a redundant value that's no longer used or needed, which is fine for now, right? Now, the next thing I did was to ask the user to enter a 3-digit number. And I store that into a short and not a byte, because a byte holds a number no greater than 127. For a short could hold a much larger number. In this case, the value will be 32,767, but nothing greater, which is fine because I'm only trying to hold a 3-digit number, not a 4 or 5 or greater, and nothing smaller, which short suits me perfectly fine. And by using this, I save more on my computer memory to do something else, right? You don't want to have to use up all your memory, right? You want to be memory efficient. All right, so in here I create a label called outer scope, and the reason for this is because I want to just perform all my logic within this scope right here, which goes all the way from here. And the reason for that is I just want to do all the checks I need, and then once I'm done, I want to break out of it. I don't want to waste any more time within the program. I don't want it to create unnecessary data right here if I don't need to. It's just going to do a check, and if it fails this check, I want it to jump out of this scope, and the second it jumps out of this scope, it'll go to all the way to this curly braces here and continue on to the next line, which is this switch case right here, which is just a few lines of code. By doing this, it's more efficient and cleaner for your program. All right, so this outer scope contains all the logic to check if the user win or lose the lotto game. All right, so the first check I want to do is to make sure that the user enter a 3-digit number. If the user did not enter a 3-digit number, then I'm going to ask the user to enter it one more time. And if the user did not enter it correctly the second time, which is the second chance I gave the user, then I'll instantly set the chance to 0 and break out to the outer scope. Of course, right here, you don't have to name it outer scope. You can name it whatever you want or suit your programming. Right? Second jump out to outer scope, chance have now been set to 0. All right, since chance is a variable outside of this outer scope, it exists. All right, and by that I meant if you were to use lotto A outside of here, right, outside of the label lotto A, it does not exist. Okay, and earlier I said, hey, if the user didn't enter a 3-digit number, I gave the user another chance, and that user ruined that chance. Chance has been set to 0, and it'll jump straight to the switch case, and it'll go case by case, and it'll see, okay, case chance is 0, therefore it's going to print this out and then break, which means it'll break out the switch, goes here, and there's no more code for it to run, and it's pretty much done. So it'll say, hey, if I gave you that chance and say you did not enter a 3-digit number, the game no longer will run. All right, but if the user didn't fail, in fact actually enter a 3-digit number this time, it will fail this if case, this if right here, and then it will continue to the next if, and it will do a check. And if this check match, set chance to 1, go to the switch case, do what it need, check what it needs to check, display what it needs to display, and end the game. All right. So if this happens, the Java program doesn't need to waste memory to create more variables right here. Lotto A, B, C gets A, B, C, right? And that's exactly why I put it underneath. I don't want to create these variables if it's not going to be needed to be used. I don't want it to calculate all these math functions if it's not going to be used. But if it is going to be used because it never break out to the outer scope and continue, then I'm going to continue to do all these other checks right here. All right, and once it's done with that check, and if it ever needs to break out the outer scope, break out here and go to the switch case, it will run through each case and display what it needs to display and break out of it and finally end the program. All right, so I've spoken more than an hour, which is longer than I've ever done before. I doubt anyone has seen it this far. So this is where I'm going to end the exercise.